In this video, we want to prove by contradiction. So there's a question here that says prove by contradiction that the square root of 2 is not rational. So the first thing you need to do if you are proving by contradiction, you have to assume that the square root of 2 is rational because they said it is not rational. So you will say suppose that the square root of 2 is rational. So if the square root of 2 is rational, then it can be expressed in the form of a over b, where b does not equal to 0, because a rational number is a number that can be expressed in terms of a over b, whereby b does not equal to 0. So we will say let the square root of 2 be equal to a over b, where b does not equal to what? Does not equal to 0. So from here, then you will add some information about rational numbers, that the common factor between a and b must be 1. The common factor between a and b must be 1. So you will say the common factor between a and b is 1. It must be 1, not greater than 1 or not less than 1. So from here you will then say, okay, since I have the square root of 2 on the left hand side and a over b on the right hand side, now I want to make my a the subject of the formula. So upon making my a the subject of the formula, I will square on both sides. So you have square root of 2 is equal to a over b. Then you will square on both sides. Upon squaring, it will be like this. Then from here you have the square root sign and the exponent 2. So the square root and the exponent will eliminate. Then you will be left with 2 on the left hand side is equal to a squared over what? Over b squared. Now you have 2 is equal to a squared over b squared. But your main aim is to make a the subject of the formula. So upon making a the subject of the formula, you have to multiply on both sides by b squared. So if you multiply on both sides by b squared, you will get 2b squared is equal to what? Is equal to a squared. Now, if you can observe that a squared is equal to 2b squared, it simply tells us that 2b squared is a multiple of what? Of a squared. So we will say 2 is a multiple of what? Of a squared. Since 2 is a multiple of a squared, therefore 2 is also a multiple of what? Of a. 2 is also a multiple of a Okay, 2 is also a multiple of a. Then from here, since we said that 2 is a multiple of a squared and 2 is also a multiple of a, now we can say that a is equal to what? A is equal to 2m, because a is a multiple of 2. Oh yeah. Then where there is a, we can replace it with 2m. Where there's a, we can replace it with 2m. Initially we had 2b squared is equal to a squared. Now we will substitute a with 2m. Upon substituting, we will get 2b squared is equal to 2m all squared, because we are replacing our a with what? With 2m. After replacing a with 2m, you will then simplify. You have 2b squared is equal to, what is 2 squared? 2 squared is equal to 4. What is m to the power of 2? M to the power of 2 is equal to m squared. Now you have 2p squared is equal to 4m squared. Then from here, you can divide on both sides by 2, right? So upon dividing on both sides by 2, your yield will be p squared is equal to 4m squared over 2. But now, I am observing something. We said that the common factor between a and b must be 1. It must be 1, not greater than 1 or not less than 1. In this case, we are having a common factor here, and our common factor is 2. Now we can then write the statement which says that the common factor between 4 and 2 is 2, and that contradicts with our initial assumption, which says that the square root of 2 is equal to a over b, where b does not equal to 0, and the common factor between a and b is 1. Now, if you can simplify this, your b squared will be equal to what? Will be equal to 2m squared. So b squared is also what? Is also a multiple of 2. B squared is a multiple of 2, which means that b is also what? A multiple of 2. Therefore, this contradicts with our initial statement, which implies that the square root of 2 is not rational. By contradiction, is not rational. Yeah. And that is how we solve, or that is how we prove that the square root of 2 is not rational upon using proof by contradiction. So the first thing you need to do, you have to assume that the square root of 2 is rational, and you will say let the square root of 2 be equal to a over b, where b does not equal to 0. After that, you square on both sides. After squaring on both sides, you say a squared is a multiple of 2, which means that a is also a multiple of 2. Then you let a be equal to 2m, and you substitute your 2m where there is a. After that, you come with a conclusion which says that there is a common factor between a and b, and the common factor is 2, which implies that b squared is also a multiple of 2. Then b is also a multiple of 2. So the square root of 2 is not rational, because this statement here contradicts with our initial assumption that the square root of 2 is equal to a over b, where b does not equal to 0, and the common factor between a and b is 1, because in this case our common factor is what? Is 2. Yeah, that is how we prove by contradiction. So you can comment on this video, you can make a suggestion, and also subscribe on this channel.